all had a nice day. All right. We'll be starting off today with NumPy. We stopped at NumPy last class, so we'll continue from where we stopped during the last class. But hope we are all doing very well. Happy Democracy Day to our Nigerian folks. Hope you had a nice time. All right, so let's get started. Like we do, I would be training for 30 minutes. Then we'll do a quiz break, 5 minutes, train for 30 minutes. Then we'll have more of open forum today so that I can take as many questions as possible. All right. Okay, we have just few people on the call. Is it because of the Democracy Day or what's happening? But hopefully they will join us as we proceed. Okay, thank you for the persons that have been submitting their exercises. Well done, well done. You all have been doing a great job. Well done. Yeah. Okay, so we did NumPy last class, and we stopped at NumPy subsetting, indexing rather. I think I covered almost everything on indexing during the last class, but I just want to go over some part a bit again for the sake of persons. Some persons were not really getting it very well, so I just want to touch on the indexing of the 2D array again. All right. So that's where we're going to start from today. Okay, trying to admit more persons so that they can also join the call. Okay, so indexing, like I mentioned about NumPy during our last class. NumPy numerical Python. It's a Python library that helps in doing a lot. I mean, advanced computational expressions. When you have advanced computations, you find out that you can use NumPy to handle such computations. And we went through some of the basics of NumPy, how to create arrays, the different type of functions we have in NumPy, and then the indexing of the arrays. We looked at the different dimension of arrays. We saw the 1D array, and now the 2D arrays, like that is also known as matrices. Okay, so during the last class, we're trying to do indexing, and for people that follow through the Python lists classes and the dictionary, it's just similar. The indexing is quite similar. The only difference is that in arrays, you're dealing with a two-dimensional array, and so you have it in a more technical format, but it follows the same format if you're able to follow through. So I'm going to load my import NumPy as MP4. Anytime you're using the NumPy package, the first thing is after installation, the first thing is to import it so that you can reuse it. So we went through this last class and went through all the functions, the range, reshapes, and all of that. So I'm going to go through the indexing again for the sake of some persons that didn't really get the indexing. Okay. All right. So given this range, we can create a range of values. The range function helps us to create a range of values from the start and to the stop -1. That is, if you want to create a range of values between 5 and 15, 5 to 14, your start index will be 5, and then your stop would be 15, because it's the index, the last index +1. That is, if you want 5 to 14, you have to add 1 to your formula. All right, so this creates a range of an array with a range of values from 5 to 14. So the dimension of this array, if you check the length of this or the shape of the array, arr.shape, you find out that it is a one-dimensional array. That is an array with 10 columns and one single row. All right, so to index this particular array, it's just similar to you indexing a list. And the first thing you have to do is the name of your variable, which is ARR, then is square brackets. And for example, I want to index out numbers 6 to 9. So number 6 is at location what? 1. Number 6 is at location 1. So I can say that ARR square bracket 1 full column. Then I'm going to continue to count. Let me count let me get to the location 9. Let me know the position of 9. So 5 is 0, 6 is 1, 7 is 2, 8 is what? 3, 9 is 3, 9 is 4. Because we want 9 inclusive, you remember that arrays or indexing arrays are based on zero-based indexing, just like lists as well. So you can say ARR 1 to 5 because this last value is at location 4, and your stopping in the index is usually +1. That is, you're going to have to add 1 to it so as to include this top index. All right. So having that gives you 6 to 9. So I think we are clear with the indexing of the one-dimensional array. But then if you have to index a two-dimensional array, how do you go about it? It's still the same format, but then you just have to pay some extra attention so that you'll be able to you wouldn't make any error. Okay. So I'm going to go to the index of a 2D array now. Please let us try to come early so that we won't be obstructing our learning, so that we won't have to be admitting people while while the training is going on. Okay, because there are some persons that just get into the lobby and we need to have to admit them. Okay. Welcome to the persons just joining. Please let us try to come early next time so that we don't get to miss out from what we are learning and we don't get to eat into our time as well. Okay, let us continue. Let's proceed. All right. Having understood the indexing of a one-dimensional array, let us go to the two-dimensional. Okay, let me take one more. Okay, if for example you want to index 10 to 14, okay, 10 to 13, let me use 10 to 13. The first thing to note is you have the name of your variable, then 10 is our location words. Let us count 0, 1, 2, 3, 4, 5. Is our location what? 5. That will be the first index. 5, 2. Then what's the last index of 13? We have 10 is at 5, 6, 7, 8. 13 is at 8. But because we want 13 to be inclusive, we're going to add one more to the index number so that we can include 13 in our result. So that's why we're having 5 to 9. And that's how to index a one-dimensional array. Okay, so moving to the two-dimension now. Okay, moving to the two-dimensional array. This is a 2D array. created from a Python list or list. So a 2D array is just like you having a list inside another list. This is the first list, right? This is the second list, the third list, okay? And having this 2D array is just like you saying that, let's check the shape of the array. It's ARR2D. This is a 3x3 matrix. ARR2D dot shape. And that will give you, that is telling you that we have 3 rows, 1, 2, 3, and 3 columns, 1, 2, 3. So given this particular array, if you want to index out 40 to 45, that is just these 2 elements, how do you do that? Now, the first thing is the variable name, that's AR2D, the square bracket. Then 40 to 45, we are starting from the row. You start from the row. 40 to 45 is at what row? This is row 0, row 1, and row 2. So is at what? Row 2. So you're going to write 2, comma. Then, because you want these 2 elements, right? What columns are there are these 2 elements? We're going to count the column this way. This is 0, 1, and 2. And remember, if you're indexing like 2 columns, you can say 1 to the end or 1, 2, 3, right? So that is why we have 1 to the end here, and that indexes 40 and 45. I believe it's clearer now. Okay. What if we want to index out just 5 to 15? How do you do that? 5 to 15 is in what? Row 0. So you can just say, you can just say ARR underscore 2D 0, and that gives us 5 to 15. So is that easy? Is that very, very explicit like that? Okay, now let's look at a more complex one. Sorry, I'm getting to admit somebody else. All right, so let's look at a more complex one, and that is this. For example, you want to index out okay, you want to index out 10 and 15, 25 and 30. That is these 4 elements. Sorry, the highlight is not covering it well. 10, 15, 25, 30. If you want to do this indexing, how do you do that? The first thing to take note is what row is this array? So you're going to say ARR underscore 2D square brackets. Want to index outward 20, 30, 40, 35, right? This is in row 1 and row 2. And how do you select row 1 and row 2? Is you're going to say 1 to the end, right? That's how you select row 1 and row 2. So we are done with the row. But then what column do they belong to? This 25, 30, 40, 45. They belong to column 1 and 2 as well, right? This is 0, right? This is 1, and this is what? 2. So you can say 1 to the end as well. Yeah. So this indexes out 25, 30, 40 to 45. I believe this is a bit clearer. Okay, so let me ask you to index out 1 for me. Can we try to index out 5, 10, 25, 20, 25, 5, 10, 20, 25 from this array? What would be the result? 5, 10, 20, 25. Can we index it out? We can use the charts for our response. 5, 10, 20, 25. Is anybody trying? Let's try the index 5, 10, 20, 25. Okay, let me check responses on the chat. All right, I'm just going to lift up our responses as is so that we can all see the results together. So somebody said, so we are trying to index out 5, 10, 20, 25. So someone said ARR underscore 2D square brackets 0202. All right. Thank you. Clap, 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 clap. Well done. Okay, let me look at the second one. 0 to the end. Oh, okay. Let me try it. 0 to the end, 1 to the end. Five, 10, 20, 25. So the person that wrote 0 to the end, 1 to the end, this is the answer. So this is what you indexed out. This part, this is 10, 15, 25, 30, 40, 45. So we're going to look at what was wrong. Let me check other answers. Okay, same thing, 0 to the end, 0 to 1, 0 to 1. All right, let me try that as well. Sorry, I'm trying to admit more persons. Please let's try to come on time so that we would avoid disrupting our classes. All right, so let me try the other ones. Let me try the other ones. Okay, 0 to 1, 0 to 1. So for the people that are just coming, we're just going over the indexing of 2D arrays. I noticed that so many persons didn't quite get it. So we just went over it again so that we can all be on the same page. Okay, so the person that wrote 0 to 1, 0 to 1, this is the answer. So this is actually what we're trying to get out. I said we should get out 5, 10, 20, 25, right? So what went wrong with this one? So when you say 0 to 1, the first, what you're doing is you're saying, I just want to select for the row, this is the row, right? I just want to select the first row, 0 to 1. I want to select this first row. And this is what you just selected. And then the first column. So automatically it selected just 5. So that's what went wrong. So for the next one, the person that said 0 to the end, right? What you selected for the first row, you're selecting 0 to the end, that is all of this. You're selecting the whole of the array. Sorry, I'm trying to highlight. You're selecting the whole of the array because this is 0, 1 to 0 to the end for the rows. Then for the column, you're selecting 1 to the end. That is from 10 to, this is 0 for column 1, 1 to the end. So everything from 10, 15, 25, 30, 40, 45 got automatically selected. And that's why you have this results. So you can see the difference. But what we're actually driving at is to select 5, 10, 20, 25. So how did the person get this? What he did or what she did was that he said that 0 to 2, because we want to select these two rows, 5, 10, 20, 25. The first thing I mentioned was what row? We start with the rows. What row do they belong to? They belong to row 0 and row 1. And how do you write row 0 and row 1? That's 0 to 2, right? And that is what that was the first input here, comma. Then the next thing is 5, 10, 20, 25 belong to what column? They belong to column 1 and column 2. And this is 0, 1. How do you write 0, 1? That's 0 to 2, right? And that would give you your result. I hope this clarifies this. Okay, we're going to do one more so that we can all get, can all be on the same page. 10, 25, 15, 30. Now this is a bit, okay, I want to do something. I want us to select 5, 20, 35, 15, 30, 45. Is it possible? 5, 20, 35, 15, 30, 45. Can we try that? Are we trying it? Or it's a bit complex? Okay, let me check the charts. We're a bit quiet. Have we tried that? Okay. Have we tried that? Okay, let me try what I'm saying here. Thank you for the attempts. It's good we're attempting it so as to try your let's see how well you get this explanation. Okay, let me try the first one. 0 to 1, 1 to the end. ARR 2D. Okay, this is the first first response. 0 to 1. Let me check the chart again. 0 to 1, 1 to the end. Okay, let me check the second person. 0 to 3, 1 to 3. Okay, so this is the second person. 0 to 3, 1 to 3. All right. So I'm trying to look at, I just tried it because I just said, okay, so what we're trying to to index out is this: 5, 20, 35, 15, 30, 45. So the first thing is ARR2D 5, 20, 35. The first thing is the row, right? You want to get out the row, and the row is this is in row what? Row 0 and row, this is in row row 1. I mean, okay, this is row 3. Okay, sorry, row 0, row 3. I just want to try this. Let's see if this thing is going to work. Row 0, row AR2D, row 0, AR2D, row 3. Okay, apparently, it's kind of tricky. I've not tried it before as well, because I was thinking that it's possible to just select 5, 20, 35. And if you want to select 5, 20, 25 alone, then you now add it together. 5, 20, 35 is 0. That is this is it. 5, 20, 35, and then the other one is 15, 30, 45. 15, 30, 45 is something like this. Then you have this 0, 1, that is all of these, and then row 0, 1 to row 2. Having this, then you do a join of the two arrays together. I was just thinking around, because it's difficult to select them separately together, because of there's a break in between this array. There is no there is no specific interval between them, so it's difficult to select them together. So it's like you select them separately and then merge the two arrays together. Okay, so thank you for everyone that attempted that. I want us to go into something else. Okay, somebody dropped another one. Let me see. 0, 0. 0, 0 is going to, we're going to have something like this. You're selecting just this first element for 0, 0. So that didn't work. Okay. If you do this, it's an empty array. It's not going to work. All right. I think we get the idea about the indexing and selection of 2D arrays. Okay, so let us move to we talked about MP.0 fancy indexing, yes, last class. If you want to create an array of zeros, right, you can just use MP.0, then the shape of that array, and then you can always check the length. There are some functions. We also looked at the functions, right, during the last class. So typically we've covered basically what we need to cover for the indexing. And then, okay, let me just mention something about the selection. Sometimes you might just want to do some selection using Booleans. So for example, you have an array of 1 to 10 using the range function. You can, if you want to select all the numbers in the array that are greater than 5, you could use the ARL greater than sign 5, and then it's going to return the array for you. Then you can also select less than, or you can use any other operational function to do your selection. It's going to also select that for you. So you can do that using an array. You can do that using array. All right. So there are also some other NumPy attributes. We have the shape. This checks, it returns the size of the array. You've seen that we've been using np.shape. Shape checks the size of the array, whether it's a 2 by 2 or a 3 by 3 array. And if you're using dot size, the size, it returns the total number of the array, total number of elements in the array. So let me use some of the examples here. For example, we have, let me look for one array that is available, maybe that we've used before now. Okay, let me use the ARR. So you can say ARR.shape. And then it tells you the shape of this array, right? Let's even do a reshape first so that we can see it better. This is 10, right? So you can do it 2 by 5. All right, so if you do ARR.shape, tells you, okay, let me run this again. Because I've already reshaped it, let me rename it so that we can have a new array. So you have ARR underscore new. So we can say ARR underscore new dot shape. You can see that it's telling you that this is an array with what, 2 rows and 5 columns. Then you can also check there are other functions you can check and check the type of the array using the .d type. .d type, it tells you the type of the array, the data type of the array. So let me check the data type of the array. So if this array is it's an integer, so we should expect an integer array. So it's telling you that the array is an integer, right? Then you can also do ARR underscore new dot size. So it's telling you the size is telling you the number of elements in the array, and that is what 10. The shape is telling you the shape of the array, the row, a number of rows and column in the array. So those are the array attributes of NumPy array, the commonly used attributes that you can find. So we'll be doing a short quiz now. Afterwards, we're going to go through a challenge together. I don't want to leave it to you to do at home. There's another assignment that you do, the NumPy reviews challenge, but I want us to do the picture challenge together. So we'll go over the use of NumPy. We're going to convert some NumPy arrays into an image, and we'll walk through each of those questions together. All right, so let us do this short quiz before we proceed. If you have any question, please, it remains one. Okay, I didn't see, which one are you referring to? I think I tried all of the attempts. I tried all of them, but none of them worked. So which one exactly are you referring to? So that I can try it again. Please, let's try to join on time so that we won't disrupt the class. I want to get off the quiz so that we'll do the quiz together. Just a minute. I'm trying to admit some more persons. Okay. So I'm going to share this Slido link so that we can try attempt this quiz together. I'll be waiting for everyone to join. Don't worry, it's not difficult. Let's just attempt it. It's 5 questions, 20 seconds for each question. Okay, we're going to get started. Let's get started. Okay, so we have the first question. How can you create a NumPy array from a Python list? What is the syntax for creating a NumPy array from a Python list? All right. Thank you, everybody. I think we all got it. Okay. Thank you all. Let's go to the next one. What is the shape of a 1D NumPy array with 5 elements? So we've been using this shape, over and over again. A 1D array with 5 elements, 1D array, one-dimensional array with 5 elements. So it's gonna lock now. All right, thank you. We're gonna see our answer is 5 comma. You remember most times when we run our one-dimensional array, it does not include the row. It just tells us the number of column, and it's 5 elements, and that's why we have 5 comma and bracket. Thank you, everybody. Okay, so we're going to go to the next question. It locks in 20 seconds. What does mp.zeros 3,4 function in NumPy do? mp.0. We have 8 np.zeros. 2 seconds, 1 second, and the answer is revealed. We have, it creates an array with zeros. You remember that when we are using .0, just know that it's you are looking at an array filled with zeros. So all this 3 by 4 is just a distraction. mp.0 It's not an identity matrix. An identity matrix is np.I, for the randoms, it's np.random. That is what you use to create the random values. For arrays with ones, use np.ones. For arrays with zero, use np.0. So let us take note. Thank you, everybody. Okay, so let us go to the next question. Locks in 20 seconds as well. So how do you perform element-wise multiplication of two NumPy arrays, A and B? We touched on that last class. Okay. This is quite it's quite tricky. All right. Let us see the answer. So they actually you could use multiply as well. I think we touched on you can use multiply as well, but you can use A times B, and if you want to use the function, you could use multiply as well. Okay. Thank you, everybody. It's supposed to be like a dual selection answer, so this will just be a bonus. All right, thank you. Let's move to the next question. How can you find the mean of a NumPy array, ARR? The mean of a NumPy array, ARR. Let's remember the use of NumPy functions. All right. Okay, so let us see our answer. It's np.mean. np.mean calculates the mean of the NumPy array. So thank you very much. The essence of this quiz is just for us to get to know more and to reinforce our learning. You know, some things have been mentioned in class, but some of them might be salient. You might not really remember. But when we do quizzes like this, it brings those things to you know, it makes us pay attention to those quizzes and to some of those things, and you know, it helps us better. So thank you, everybody. Mastura, clap, clap, clap. Sunny, Mark, Oladimeji, Osasi, Oluwada, Milari, and everybody that, you know, attempted. Thank you all so much. All right. Okay, so let us get back to class. I hope you had a little break from our lessons. Okay, so let us get back to class. So I said we're going to touch on the challenge together, and after which we'll take questions. Okay. All right, so let me just go right to that challenge. Please, if you've not submitted your assignment, please try as much as possible to do that for week 1. The assignment link is on the LMS. Please try as much as possible to submit your assignments. And we'll be having a project. So we'll be sharing, so this class, Python for Data Science, is going to end on Wednesday next week. That's where we'll be having our final class. The new class, Power BI class, will be starting on Friday. So for this class, we'll be having a project, mini project that we'll be doing together. And we'll be sharing with you details about the projects. It's going to be a simple project, but it's something that just like it's going to put together everything we'll be learning, you know, so that you can have something, you know, work on real life challenge and have something to put on your portfolio. All right, so let's have that in mind. And for the learnings, let's try as much as possible to do some catch-ups. Maybe we need to brush up some of our learnings. Let's try as much as possible to, you know, do some of those learnings at our leisure time. Okay, so let's go right into the next task we have. So when you get to the classroom, there is this challenge called the picture phrase challenge. So that's what it's supposed to be, an assignment, but I just thought we should walk through it together. There's one more assignment that I'd love us to do. So I'm going to be linking the assignment to this class so that you can try your hands on that assignment. You can also see how I'm accessing the dashboard, right? So I went to the website, then because I'm logged in already, so I'll just go to the drop-down button here. Okay, so my internet is a bit, okay, so I'll go to my programs. So because I've been registered on this program, so that program should be on my dashboard. So I can just go to view programs and then I can access the classroom. So when you get to this, when you get to the classroom, I want to show you where this picture face assignment is so that you can get to download it as well on your own. Okay, so we have NumPy. This is the NumPy assignment. So the first assignment for last week is there. Let's try. Some persons have started submitting theirs. Thank you all, everyone that has submitted. And this is the picture phrase challenge that I talked about. I want to just walk through. So you can download it from here and attempt it as I'm working on it so that you can work on it as well. Okay, so let me just go to where I have mine downloaded. Okay, so now, we've been talking about the use of NumPy. We've been learning all the bits and pieces. We talked about how to create NumPy arrays. And then we also looked at the NumPy functions, some of the functions that we have in NumPy. How do you use them? And then we looked at indexing and selection. Now, I want to put together everything we are learning in this challenge. So this challenge is usually when you're performing, maybe you want to do some sort of like an image recognition system, or you're working on so it's something related to images, right? So usually sometimes you can use NumPy to do your transformations, like transforming your images into numbers. And that's part of the use case of NumPy. There are other advanced packages you could use, like TensorFlow and tensors or PyTorch. There are some packages in PyTorch you can use as well. But NumPy can also do some of the tasks. So here in this task, there is a picture. Let me show you the picture. I don't know if I have the picture here. Okay, this is the array. This is the array of the picture. I'll check for the picture. Let me check for the picture somewhere. Okay. No. Okay, not this one. Um, okay, this is the picture that we want to convert. I mean, we want to convert text to images. This image, we're going to convert some text. This array of text that I just opened. This is the array of text. So we're going to convert. It's using all the functions put together that we'll be learning. We're going to convert these to an image. Okay. So now let us get started. I'll be asking some questions, like you sharing your your ideas on the chat as well, so that we can all work on this together. Okay. I believe this is the one I want to work on. Now, the first thing says that there are instructions in this challenge. we have to import NumPy, standard import. So because of the display of the image, there's a library called the matplotlib. I don't know if we'll be able to touch on some visualization. Maybe we could do Seaborn for let's see what we can do. Maybe we'll just touch on one or two visualization packages like Seaborn or Matplotlib. But Matplotlib is one of the packages that you can use to view your images. You can use to, you know, plot graphs. You can use it to do several visualizations in Python. All right, so we are loading this library because we'll be using it to visualize our array. Okay, so now these are just standard imports. The next thing is we want to load the image. We want to load that array text because that's the text we want to manipulate. We want to manipulate this text. So we're going to load this text using np.loadText, right? Then the name of the file, and then the data type. So that's how you load a text file using NumPy. And here we are just want to view the array. So this is the array that we want to actually convert. It doesn't look like it, but the array actually contains red, green, blue values mixed up and transformed for a picture. Let's check the shape of the data. Now, what is the formula to check the shape of the data? So this should be your answer, right? If this is not, if you're not getting this, then your formula is wrong. Can somebody just drop the formula for checking the shape of the data? I want us to do this thing within 20 minutes or maybe 30 so that we can have time for Q&A. Can someone drop the formula for the shape of the data? How do you check the shape? img.shape. All right, that's what you know, remember from what we learned, img.shape checks the shape of the data. So we have 812,160 rows, columns of values in this array. It's a list of type U32. Okay. All right. Thank you, Dami Fola. All right, so we are correct. So the next thing now is let's check the data type. Can we try what can we use to check the data type of the array from what we learned in class? What can we use to check the data type? What was the array function? Can we try? Thank you, Chima. Image.dtype. Right? That was that what you wrote? Okay, good. Image.dtype. Okay, this is saying this is U30 32 formats. All right, I was expecting a numpy.nd array. I'd loaded this, right? Yeah. I was expecting a numpy.nd array format. Okay. Let me try another. There is another function you can use to check your type formats. Let me try the second function. Can use a type function, type image, and you can also do this using our type function in Python, right? So this will also give you the it's telling you that this is a numpy.nd array. It's a numpy array, but this is also correct. This is telling you that the data type of the elements in the array is the format U32, but this type function is telling you the data type of the array itself. It's telling you that it's an array. Okay, so two of them are actually correct. So for the next task, save your output as the question number. The first two have been done for you as examples. In order to perform mathematical operations on the data, we need the values to be in a numerical format. So it's just for you to follow these questions and would walk you through to your output. So the first thing is to update the data type of the image to float and call it Q1. So here, it has been done for you to change the data type of this. You know, the data type here is a U32 format, right? It's a U32 format. But then we want to change the data type to a floating point number. And to do that, there is this function called the asType function, image.asType, then you can enclose it into float, change the image to float 64. And when you do that, you have these and you've saved it in question 1. All right. Okay, so the next task, okay, am I working on the right notebook? Hope it's not, okay. Yeah, it's the right notebook. The first two has been done. All right, so the next task says, some persons are just joining. Okay, the next task says, okay, he said I should come again. Where? I wasn't reading the chat because I didn't have the charts here. Where do you want me to come again? Is it from the data type or from where? From the beginning. Okay, I'll do this again, but because of our time, I might not be able to be going back and forth, right? So just try as much as possible to listen. They would also have the recording. All right, so let me go back from the beginning for the sake of my friends, everybody. All right, so what we are doing here is that we want to convert some NumPy arrays into pictures, right? And I explained that the array is in this format, right? This is the text format. And then we want to convert it into this image using all of the functions and everything we've been learning so far since last class. So we're going to be following a particular, different steps, processes to get to our output. So we have this text file, we want to convert it to this image. Okay, so that's what we are doing. All right, so I don't want to read all of this. I've explained what we want to do. The array was transformed using a set of specific NumPy transformation. It should be your task to transform the array back to the original by performing the same NumPy transformations. In the end, you would reshape the array and show the corresponding image associated with it. So the first thing I mentioned was we have to do our import NumPy for the NumPy transformations, and then matplotlib for displaying our images, which have been done. Then the next step is to load the text file. Now we want to use the text file. We are working from the text file to the picture. Sometimes you might have to convert pictures to text to NumPy. So it's just like a reverse engineering work. But now in this case, we are converting the array into the image format. So here, the first thing is we have to load our array. And how do you load your array? I mentioned that there are several functions in NumPy. They have their different functions. We have the array function and all of that. But in this case, this is the load.text function. And a way for you to even check what this function accepts, you can just press your tab key. After writing your array, you can do your shift tab. When you do your shift tab on your system, it gives you the doc string, like the documentation on the array, np.loadText. The first thing is the file name, the name of the file. Then these are other defaults. If you can accept the other defaults, if you don't want to. But here, we just specified the array.text, that is the array file name, that is array.text. If you look at this file name, you see it's array.text, right? In quotes, comma. The next attribute that this function accepts is the data type, and it has to be in quotes. The data type is of U32 format, right? But here, the default is float, so that's why we are specifying that, okay, the data type of this array is of U32 format. All right, so that being said, we're going to load our array. I wanted to see if the data type was specified. Okay, no, it wasn't. So here, I haven't loaded your array. I've done it before, so that's why I'm not loading it again. So you have to view your array. Now, this is, you can see that this is the array that we want to work with, want to convert it into an image. All right. Can you see my screen? If you can see my screen, just give me a thumbs up. Someone said my screen is not showing. I think it's the network. All right. So I've not seen, can you all see my screen? If you can see my screen, then I don't think I can continue because I have to be sure that you're seeing my screen. All right, great. Thank you. So having done this, right? The next instruction is, this is an array, but it contains images. I mean, it contains red, green, blue values. That is, it's like a colored image. This is an image you're seeing in a text form, but they've been transformed. So we want to transform it back, and we have to perform all of these steps to do the transformation. So the first thing is to check the shape of the NumPy array. So here, the question says, what is the shape of the NumPy array? And the shape, based on what we learned in class, is the name of the array. What's the name of this array? Is image, right? IMG dot shape, right? And that gives us the shape. So the answer is already here to check, for us to check if we are correct and we're actually on the right track. So the next thing is, what is the data type of the array? And I mentioned that somebody gave me the D type, which is correct. It's telling you the data type of that particular array. So I was saying that you can also use the type function to check the type, the data type of the, to check if is it an array or a list, or no, you're not talking about the elements now, you're talking about the entire array. You want to know what type is it? Is it an array or a list or a Boolean or, you know, other data types? So here, this is what the type function is doing, but this is correct, image.dtype. So we can see that we have a U32 format of arrays in our data. Now, the next task is that, this is the next task. Said update the data type of the image to a floating point number called float 64. And I was saying that there's another data type. I mean, there's another function called as type float. So in case, now when you're working on questions like this, if you've not come across some of these functions before, right? Maybe I've not even, you know, I didn't mention as type. I don't think I mentioned as type. But one way you can use to, you know, check, you can, when you write the name of the image and you do dots, you can do your tab. When you do your tab, it lists all the functions associated with that image. So under this this list, you can see as type. As type tells you, okay, this is maybe talking about the data type of the image. You can see other functions, data dots, D type. This type is taking you the data type. Okay, so as type converts this your data type, the data type of the image, it converts it to another format. That's the as type function. If you want to be further or double sure, you can browse how to check the data, how to convert the data type of an array to, let's try it. So I want to show you how to debug, so that's how to convert the data type of an array int to float 64. Just write it as is. Anyhow, you can see it has brought out the function for you, numpy.asType. So you just come back here. Sorry, you just come back here and use its numpy, that is the image.asType, and then you put in the what you want to convert it to floating point number, and that does the work for you. So I believe that is clear. You're getting an error while loading the array. Is the array in the same location? This array, you have to have if you don't have a text file, let me see. There must be an array.txt. Is there no array.txt in your folder? If there's no array.txt, you get an error. There should be an array.txt in that particular folder. This is the NumPy picture first. There should be an array.txt in that folder. If there's no array.txt, you'll be having an error. It should be in that same location. Okay, so let us run quickly. We have some more tasks to cover. So we've converted it to a float. And if you want to be double sure to check the data type, you could just say Q1, sorry, the D type. Sorry. You can see that it's now a floating point number, right? So the next thing says multiply each element of the array by 10 and call it Q2. So how do you multiply? Element-wise multiplication, what we learned during the quiz. The array is Q1 times 10, and then we've called it Q2. So you see that all the things you've been learning comes into play in NumPy transformations, right? So when you do that, you have this answer. So the next task is create a NumPy array called ARR of the following 5 values: 35, 32, 54, 67, 88, and 4. Use the NumPy sum method to add all the values together and store as a variable called total. Add this total to every element of Q2 array and call it a Q3 array. So after that, you should have this answer. So now you can see we are getting somewhere. So all what we've been learning will come into play. So the first task, we're going to do it together. Let me add more cells so that we can treat each of those questions one after the other. All right. So the first task is create a NumPy array, RRL, of the following 5 values. How do you do that? Somebody should try that. Is somebody trying that? Let me check. All right, let me just walk through it so that it's just literally, you could just do ARR is equals MP dot array. Then you have a list 32, 64, 67, 88, and 4. Now, create a NumPy array called RRL. That is, the variable name should be RRL with of the following 5 values. So these values are a list. You want to convert into array, and then you have this ARR, right? That's the first question. Use the NumPy sum method to add all the values together and store in the variable called total. So total is equals to mp.sum ARR total. So you can see that all what we've been saying, talking about, they are coming together. mp.sum, that's the sum method to add all the values and store in a variable called total. So the mp.sum sums up all the array, all the elements in this array, and then you have the total. Add this total to every element of Q2 array and call it this new array Q3. So now we have a task. We want to add total to every element in this array. How do you do that? Can someone try that? What do we do? Okay, somebody said Q3 is equals to Q2. Q3 is equals to Q2 dot plus total. Okay, let's try that. Sorry, let me try. Q3 All right, thank you. So we can see that our answer is looking alike, right? So that is just the basic step we should take with that. So let's move to the next task. The next task, so we have up to 20 tasks to do. So we need to move really fast so that we can, have time to take questions. So in task 4, add Q3 array to itself and call it Q4. This would add the corresponding value to itself. So Q3 array to itself and call it Q4. So that's Q4 equals what? Q3 plus Q3. So this is it, right? Moving forward, now I want us to try this because I've mentioned linspace in class. Subtract 1 from the first element in Q4 array, 2 from the second, 3 from the third, and n from the nth, and call the new array Q5. You should not do this using any type of loop, as that wouldn't be efficient. Think about creating a second array that could be used in combination with the first array to complete the task. NumPy linspace method may come in handy here. Can you remember what the linspace do? And what it does? Can you remember the linspace function? So now the task here is we want to subtract 1 from the first item, 2 from the second, 3 from the third, till the nth value. So how do we do? How can we do this? Can somebody try before I put in the answer and explain? Can we try? Let me check the charts if we have Can someone try this? It's kind of technical, but let's see how far we can go. I hope I've not lost anyone. But we have some NumPy gurus here. Okay, let me see. Let me see what you're thinking. Size Q4 is equals to Q4 dot size. Okay, let's look at it step by step. Q4 dot size. Okay, Q5 equals Q4 minus np dot round, np dot linspace. Great. 1 comma size Q4 size Q5. Okay. Let me try what Ishako did. Let's try it. So there are several ways to work around this. Let me try its method. Don't worry, I will explain for people that might not quite get this quickly. Okay, great. Q5 equals Q4 minus np dot round. Okay. Np dot linspace 1. Okay. Okay, I would have loved to unmute Ishaku to explain what I don't know. Sorry, hope I'm pronouncing your name well. To explain what he did here. Let's count. Do you want to talk? Let me give you the floor so that you'd explain. Would you like to talk, or I should just go ahead? Okay, do you want to explain how you got the answer? You can talk if you want to. Okay. So if you don't want to say anything, let me just let me continue so that because of the class. Now the question says subtract 1 from the first item in the Q4 array, 2 from the second, 3 from the third, and all of that. Now the first thing to note is how do you have to create an array that would give you an order from like a linearly spaced order, such that you have 1, 2, 3, 4, 5, 6, 7. And how do you create? You remember when we're doing our linspace, we do np dot linspace. A linspace function creates what? An array with, if you say linspace 1 to 5, I want 5 items, it gives you an array with linearly spaced 5 arrays. I mean 5 elements with linearly spaced item. That is, the first one is 1, 2, 3, 4, 5. If you can remember the function when we talked about the linspace. So here we want to create something similar, because this is the array that we want to, the array that we want to create, right? We want to create an array such that the first item, the first item will be 1, second item will be 2, the third item will be 3, till the nth item. So, and here, the next thing to do here, the next logical thing to do is that we have to check for the size of this array, because we want to subtract 1 from the first item, 2 from the second, 3 from the third, 4 from the fifth, and to the nth item. And to do your subtraction, they have to be of the same the same shape. They have to be of the same size. So logically, so that's what Ishaku did here. The first thing is to get out. I want an array from number 1 to the size of this array, the size of our Q4. That's why he did size Q4. That is, what is the size of Q4? The size of Q4 is what? 812 160. So the first item here will be 812. Let me just use the 812 160. And then I want from number 1 to 812, but then I want them in the order of 1 to 812. So that's why I'm going to supply, I want 812 elements, 812 160 elements. So it's going to give me a linearly spaced value from 1 to 812. I hope you are getting it. Now, we're not stopping here. We've gotten this linearly spaced value, but the question says that we should subtract each of these elements from this one minus this one minus this one. So you can see that 31 minus 1 will give you 340 minus 41 minus 1 will give you 340. 50176 minus 2 will give you 5017. Sorry, 50178 minus 2 will give you 50176, like that to the end. So the next logical thing to do is to save this answer. So why Ishaku did a round, he did np.round on around this thing so as to round up any decimal points. So that's why he's doing the round. So the next thing to do is to subtract your Q4, this array, from this linspace. So when you do the subtraction, you get this answer. Do we understand? So that's just basically what he did here. The first thing was to check for the size of this linearly spaced this array, check for the size of the array Q4. I haven't checked for the size. Use the np.linspace to create an array of linearly spaced values so that you can subtract 1 from the first item, 2 from the next, 3 from the next, till the last item. And how do you do your subtraction? You just say this array minus this array, and that is what it's doing here. Q4 minus this array that was generated, the linspace array, and that's why you have Q5. I believe we understand this. I'm not muted. I think it's the network. Can you hear me? Can you still hear me? Can you hear me now? All right. Can you all hear me? Okay, I think it's the network. I can hear. I think it's the network. When we listen to the recording, we'll see that it's clearer. It's because of the network. That's why we are having issues of hearing and the rest. Somebody can hear me. So did we get that explanation? I want us to move on quickly so that we can continue from where we stopped. Okay, let me just take it again for can you hear me so that when I'm taking it again, it's to be clearer. The recording is available though, but then let me just take that again so that you can understand the other steps that going forward. So the question, right, is that subtract 1. This is the array we are looking at. We want to transform this array to Q5. This is question 4. It says subtract 1 from this one, subtract 2 from the next element, subtract 3 from this, subtract 4 till you get to the nth item, right? And call it Q5. So how do you achieve this? We can achieve that by creating a new array that would give us intervals of 1, 2, 3, 4 to the nth item. So, and that's why we are using the linspace. The linspace method, what it does is that it gives you an array of linearly spaced values. Like if you want 10 linearly spaced values between 1 and 10, you can say np.linspace 1, 10, 10. It gives you, when you do that, right? It gives you linearly spaced value from 1 to 10. So, but then we want to generate linearly spaced values from 1 to the length of this array, because we want to subtract each of these values from each of the elements. And to do that, it's just like you want to subtract, if I want to subtract, I have an array of 1 to 10, right? And I want to subtract 1 to 10 from each of those elements in the array. I have to have another array of 1 to 10. So you have to have another array of equal lengths before you can perform that operation. And how do you generate that length? You have to first of all, find out what's the length, what's the size of this array. And that is what was done here. Q4.size tells us the size. The size is what? 81210. So you're going to say, I want an array of linearly spaced value from 1 to 812, 81 to 160, right? And I want 81216, that because that's the syntax of the linearly spaced function, linspace function. I want an array of 1 to 1 to 812610, but I want 812610 elements. And that gives us 1, 2, 3, ... Because it's so much, we can't have everything listed here. So that's why it's giving you 1, 2, 3 till 812160. Now the next task is, they said we should subtract each of these elements from each of these elements. And how do you do your subtraction? It's just saying this minus this, right? That's what you're supposed to do. This one, Q4 minus this. And that is exactly what was done here. Q5 is now Q4 minus this NP.round is just to round the elements into whole numbers, but it's not really necessary, right? It's not really necessary because they are already whole numbers. It will still give you the same answer. So if you say Q4 minus NP.linspace, this is it. All this one is this, right? You're just saying Q4 minus this, and that gives you the result that we are looking for. Do you understand now? Do we understand? If you don't understand, you can you would listen to the recording, right? So that we can quickly cover the rest. Okay, so now we have sorted Q4 5. Now let's go to the next question. We want to create a copy of Q5 because some of our manipulations might alter our original array, right? We want to save that copy. And how do you create a copy from from the last class's explanation? You can just say Q5.copy will create a copy. So having created a copy, now you have a new array called Q6. The next thing is what? Update the first element in Q6 array to 4, 6 to 2, 5. Now, I believe this everybody should be able to do this. Let me just do. Now, this is Q6, right? We want to update the fourth element in this array. How do you update the fourth element? Can someone try it? How do you update the fourth element? Remember that Python is zero-based index. How do you update the fourth element in this array? Can somebody try that? Because of our time, Q6. The fourth element is at index what? 3. At the moment, the fourth element is this. This is the fourth element we have at index. This is the fourth element. The fourth element is 0.0. Now we want to update it to 4, 6, 4, 6, 2, 2, 5. This is just what you need to do. This is how to update the fourth element. So when you do that, your Q6, let's check the new Q6. Let's check the new Q63. You can see that it has been updated already. What you just need to do is to select that fourth element, right? Which is at location 3. Equals to, and equate it to the new elements that you want to update it to, and that's what we did here. And if you check, you remember that when we did the first check, it was 0. Now it's now 4, 6, 2, 2, 5 that's been updated to. So we can now print out our results. We see that the answer is still the same, right? So the next task now is create a copy of the array Q6 and save it as Q7, which has been done here, right? Then select the indices from 1,000 to 200,000. You can see all that we're learning is coming to play in image transformation. Now, for beginners, a lot of people might be thinking, oh, this is too technical and all of that. So you can take your learning gradually, right? With time, with a lot of practice, you get to know all of this very well. But don't get overly, if you're not getting it now, don't worry, you're going to get it. And most especially if you want to go into image recognition systems and you want to go into deep learning, you want to work with more of image data, like people in the medical line, medicine, and some of all those other fields that requires images. Yeah, so you can just pay attention to it. But then it's not don't be too hard on yourself if you're not getting it now, because it's not I understand for beginners it might be a little bit challenging. All right, so for question 7, They said select the indices 1,000 to 200,000, including element 200,000, and the indices 400,000 to 600,000, including element 600,000 in Q7, and add 255 to only those values. Somebody has done it. Thank you. So let me just do the explanation. All right. Okay, so we want to select the indices from 1,000 to what? 200,000. How do you do that? Q7. How do you select the index from 1,000? They've told us from 1,000 to what? To 200,000 inclusive. So we are going to stop at 201,000, 200,000, sorry, 2000, 200,001, right? Elements. And then the indices from this one as well. Q7, 200,000. It said, and indices from this, including the 600 elements in Q7, and add 255 to only those values. So this is what you're going to do. First of all, when you select it, this is it. If you want to add 255 to it, you can just do 255, right? Okay. And you're going to, because you are updating it, right, you're going to equate it back so that you can get the updates, so that these locations can be updated, just like what we did in this one. Because we wanted to update the elements at location 3, we had to select it, equate it. We have to equate it back into the selection. So that's how to update that element. So here we're going to equate it back the same way you're going to do for the next one. Q7 from 400,000 to 600,001, because we want 600,000 to be inclusive, right? Equals this. Oh, I thought this is going to just take 30 minutes, but because of several explanations. So now select the indices from 1,000 to 2,000, 2,000, including 2,000. So it's going to be 1,000, 2001 plus, and indices from this 400,000 to 600,000. So it's going to be 600,001. Add 255 to only those values. So we are going to add 255 to only those values, and we are updating our answer. So we have this. So we're going to, our new Q7 would be this, which when we check it, we find out that it's the same thing. So you might not really see it yet, but let's continue. So to code check, to confirm your code check, your code, let's check the value of Q999. Let's see if it's going to give us the same value. Yeah, Q99 is giving us 62,250. Let's check Q9 1000. Q7 1000 is giving us 349, which is correct. Q7 600,000, 341, correct. And Q7 600,001. So we are satisfied that our code is correct, right? So that solves that. Okay. Now the next thing to do is the question says copy Q7 array and call it Q8, which you've done here. You've created a copy. Reshape Q8 array to a 2-dimensional 2-column array. Now, how do we do that? Our reshape function comes into play. How do we reshape Q8 to a 2-dimensional 2-column array? So how do you, can somebody try that? Can somebody try that? What would it be? One should reshape it. What will be the shape to a 2-dimensional 2-column array? So at the moment, this is what Q8 looks like. It's a 1-dimensional array of about 800 and something. This is the way Q8 looks like. Now, I want to reshape it to a 2-dimensional 2-column array. How do we do that? Remember that when you're reshaping, right? It has to be if you have a size, if the size of the array is 10, it can only reshape it to like 2 by 5 or 5 by 2 or 1 by 10 or 10 by 1 because of the multiplication of those the multiplication of the sizes has to be equal to the length. So let's take note. So here, when we reshape it to a two-dimensional, this in this case now, just 2 columns, just 2 columns, and two-dimensional array. So somebody gave me reshape is like this. Somebody gave me an int in class. Let me see. It said size over 2. Okay. All right, great. Okay, so because I want it to be a two-dimensional 2-column array, right? It's just like you have a 10 array of 10 elements. I want it to be 2 columns, so it has to be 2, 5, right? That is, you have to divide the elements by 2, and then you want the multiplication of the 2 item. It can be for example, now if you have an array of let me give an example for the sake of people that you have an array A. Now you have this array of 12 elements, and they said we shape it to a two-dimensional 2-column array. What you're going to do is it can be 3, 4, because that would be what 3 rows and 4 columns. I just want an array with 2 rows and no matter the number of columns, it has to be 2 rows and the other column. So instead of me doing 3 by 4, yeah, I can have 1 by 12, I can have 2 by 6, I can have 3 by 4. So I'm not going to do 3 by 4 because I want a two-dimensional 2-column array. So what am I going to do here? I'm going to divide 12 by 2, right, to get 6. So my reshape function will be a.reshape. Um, 2 by 6. So this is a two-dimensional, okay, sorry, 6 by 8. Because I want just a 2-column array. 6 by 2 rather. This is a two-dimensional 2-column array. No matter the number of rows, it's a 2-column array, just 1, 2. So this is what we want to achieve with this particular array. So what are we going to do here? In this case now, this array is quite long. You cannot easily divide. So what you're going to do, you're going to divide the length of this array, right? The length of the array by 2. And that was what Ishaku did. He got the size and then he divided it by what? Divided it by 2. And then the size comma 2. That was what he did. Just like the size, that is 12 divided by 2 give us 6 comma 2. So that's what we want to do here. So what are you going to do here? This is the array Q8. So you do Q8 dot size is what? This is the size. So our range function will be what? I mean, our reshape function will be what? This dot reshape. The size now, that's this 8, 2, right? Divided by 2, because we want it to be a 2-column array. So we're going to have Q8, or you can just equate it to you can equate it to S or something. Can just say so as to get can just say S divided by 2, comma 2. And that reshapes your, sorry, okay, because I didn't load this, saying S is not defined. Okay, what's the challenge? Let me see. Okay, let me just do the expression here so that to avoid any unnecessary confusion. Okay, cannot be interpreted. It's a floating point number. Let's convert it to an integer. Okay, so you can see that we have our answer now. So you can see when you compare this and this together, you see that they are the same thing. All right. I hope we got that. It's similar to what Ishaku and Oluwadamifola did too. It's the same thing. All right. So it's just for you to just think through the process. What am I to do? How do I get to my answer? And then you find out that you arrive at that particular answer that is needed. So we've reshaped this array Q8 to a two-column array. All right. So now the next thing is what? Copy Q8 array and call it Q9, right? Swap the two columns from Q9 array, from this Q9 array. In other words, the first column will now be the second and second will now be the first. Now, I didn't teach us transpose. So how do you arrive at this? What do you do to get to this? The next thing to do is you can either check Google if you've not come across something like this before. Maybe you can just say how to swap columns in an array or something. NumPy array. And then you see several different you can just look through the article, and let me just check gigs for gigs. I actually know I know the answer, but I just want to show you how to debug in case maybe you're running into you're doing a personal project or something, so that you know what exactly to do at every point in time. Okay, network is a bit slow, but let me just proceed. So when you check online, actually you have to you see the answer. You find out how to do it. You see examples of different people that have done the same thing, and then you can easily do yours as well. So we're going to do something. I want to show you. There's something called the dot flip function, np.flip. You can use it to flip two different arrays. You can use it to do a transpose of your array. And let me show you the function. Can you still hear me? Sorry. So what you're trying to do now, this is Q9. Oh, sorry. Q8. Q8 is this. We've reshaped Q8. So let me just copy the Q8 back into this so that we have our reshape function Q8. So this is our reshaped array. Now you want to transpose, like you want to flip it. You want to all the elements in this row 0 becomes row 1 and row 1 becomes row 0. So there are several ways to do it. There's a dot flip function. Let me create this copy first. You could say Q9. So the Q9, this is what Q9 looks like. So when you use your dot flip function, you could say Q9 dot flip the array Q10 or Q9 axis equals 0, 0, 1. Okay, sorry, I'm mixing it up. It's I was doing a reverse transpose. Sorry, you can use, just let me use this. I'm coming. We can use the selection to do the flipping. We could use the selection. Sorry, I was mixing it up. We could use the selection. What you could do here is that this is this row, you want to move it to this place, and this row, you want to move it to this place. So the first thing is you can do select all this row, comma, reverse it 1, 0. That is, you want to move each of this row, everything here, you want to move it to this place, and this one, you want to move it to this place. So the first thing is to select all the rows, right? Comma, then this way, when you do this selection, that is, you're moving everything in row 1, row 0 to 1, and 1 to 0, and that gives you the reverse engineering of this. Somebody dropped something on this place as well. Okay. Yeah, yes. Okay, similar to what I have here as well. Okay, great. Yeah, so that's how to do a swap of the two columns. All right, so this second one, that's the Q10, is the reverse order that I was saying that we could use the dot flip. That is, what you're doing here is, it said copy Q9 to Q10, and then reverse the order of the rows of Q10 in the array. That is, you want to, if you look at this first array, want the bottom array to be on top, and the one on top to be at the bottom. So you can, that's why I said you can use your dot flip function to achieve that. I hope we are still following. I hope I've not lost anybody. I don't know why the network keep kicking people out. A lot of people have been, in and out here. So let's just continue so that we can get to the image. All right. So to do your reverse order, you could use your dot flip function here. This is the dot flip function I mentioned. I was trying to refer to. So when you do your np dot flip, then because you want to reverse based on the row format, that is Q10 equals is equals to np.flip Q10 axis equals 0. Is axis equals 0 because you are flipping the rows. You want to flip everything on the bottom row. You want to make it on, you want to bring it on top 124,609 and 474. You want it to be the first row, and then you want the first row to be the last row. So because we are referring to row, you use your axis that equals 0. And so when you load your Q10, you have this answer. Oh, sorry, I didn't do a copy. Hope it has not tampered with my it has not tampered with my outputs. Let me go back to load my output from here. It's to Q9. So here, this is the array 124,609,474. We want 124,609,474 to be on top, right? 124,609,474. Let's do this. Okay. I don't know why it's not giving me the exact answer I'm looking for. Access equals 0. There must be a mix-up somewhere. It's turning the axis. Let me check again. Let me reload my Q9. Copy Q9 and call it Q10. All right. reverse the order of the rows in Q10 array. So that's np.flip Q10, comma, axis equals 0. Let me first of all load Q10 to see the outputs. Q10. Okay. All right. I'm getting a wrong. I'm supposed to have this 50176. They have, that's why you need to copy correctly so that we don't have errors. So let me see where my error is coming from. I think it's from the top. Let me go back to question 8. Question 7. Let me reload this. Question 8. Okay. Copy question 8 into question 9. All right. Now I have question 9. Okay, I haven't had question 9. Let me do the conversion, the flipping. So the flipping now, I've flipped it. Okay, so I should have this. Now this is question. Okay. Question 9 dot copy. All right, I've seen where my error is. So I'm supposed to create another equate question 9 to question 9 so that I'll be able to have the new copy. All right, great. Okay, this is where the error is. Okay, so let's take note of some of this, some of these little errors. Okay, so now if I'm going to do my flip, I can see that my flip is working well now. Let me load my question 9. Okay, so now I want to do a flip of 9 to 10. Okay, I'm still having, sorry. Okay, so I should have this answer 1249 and 1249, 124609 and 474 at the top. So there is a mix, there's still a mix up somewhere. I'm just trying to check where I'd mixed the codes up. But then this is the formula for the flip. When you do np.flip Q10 equals axis equals 0, it flips the picture for you. So I'm supposed to save it into Q10 and then have another Q10 here. Sorry about I noticed that some persons are really having challenges going through this. But if we're able to get, I just want to show you the application of some of these concepts that you've been learning so that you see how well you can apply it to your own personal projects and all. So I don't know why this this is my copy that I created, Q10, and then np.flip Q10 equals axis equals 0. Yeah. Not axis equals 1, it equals 0. All right, okay. I don't know where the mix-up is, but then this is the answer we're looking for. Okay, and if you check the code check, it's the same thing. Our time is fast spent, so I'm going to rush through the remaining output so that we can have the recording. All right. So moving forward, we want to create a copy of the array and call it Q11. After doing that, set Q11 to the 101st Q11 101st row. Set it to 101 row, right? Set it to Q11 101st row. This is it. Set it to this. 101st row, that will be 100 and but that's the 102 row because it's a zero-based index. Q11th 101st row, set it to the code that we can see. Okay. Sorry, 101st row, that is, it's from 0 to 100. So 101st to be 100, 101st row, because I want the row and all of the column. This is what I would have. I want to set it, I'm going to set it to this. And when I do that, this is what I'm going to get. All right, so I can reload Q11 to see my answer. So my answer should be the same with this. All right, so copy Q11 and call it Q12. Set the elements in Q12. Set the elements in Q12 101st row to 4, 6, 5, 6. The second element in that row should remain unchanged. Okay, so in this case, they said we should set just the first element in Q11 1101st row, but the second element should be the same. So how do we do that? So that means we are referencing this Q12 100. That's the 1000 rule, because if they say 101st row, we are referring to that the 1000 rule, because it's a zero-based index, comma. The second element in the row should remain unchanged. So comma 0 should be equals to when we extract this is 100. That's the first element. So it's going to equate it to 46656. And when you do that, you have this. I'm trying to be fast because of our time. So our answer now is what? Q12. Okay. We can see that, okay, we are still on track. Now the next step says subtract 125 from every element in the second row for Q13. Now every element in the second row for Q13, in Q13 you have, this is Q13, you have the first row and first row and second row. So every element in the second row of Q13, we said we should subtract 125 from it. And so how do we do that? Let me do that quickly. Every element in the second row of Q13, we have to subtract, let me just put this, minus 125, and that gives us we are subtracting 125 from every element in the second row of Q13. I hope we are still following me. I know some persons uh are just struggling to keep up, but don't worry. When you look through the recording and you're able to follow through some of the explanations we've been doing over time, you'll get the way to go about it. So the next question says take the square root of every element in the first column of Q14. So we're going to look at every element in the first column of Q14, and then we're going to take the square root of every element in the first column of Q14. So let me just do that. That's using we can use our np.square roots. np.square roots Q14. Every element in the first row, that is all the, every element in the first row of Q14, that is the 1 or 0 now. first row, that is 0. Then you can just say NP the square root of Q14, NP the square root, NP the square root of that same element. So we want to take every element in the first row of Q14. So this is the first row of Q14. Every element here. So that is all the rows. That's why we're having the full column, comma, the full column, yes, full column, comma 0. That's the elements in all these rows. That's what we want to take the square root of everything here. And that's why we have this Q14. All right. Oh, sorry. I didn't load this. So you can see that we've taken the square root of all the elements here. So the next thing says to check your results, these two have to be the same thing. Yeah, they're the same thing. All right. So now the next thing says change any value in Q15 that is currently 999 and set it to 117. Okay, so it wants us to change any value in Q15 that is currently 999. So the first thing is to check for all the values in Q15 that is currently 999, and then we'll now update it to 117. So that's what we want to do. So how do we do that? We can use our selection Q15. Let me load this first. Q15. Every element in Q15 that is currently 999. So this tells us all the elements in Q15 that is currently 999. You can see everything here. Now, what are we going to do? We want to update it and change it to what? 117. So we're going to just do this equals 117. And then we are updating everything to 117. And that automatically does that for us. Q15. Okay, see all of this work just to transform NumPy to image. Now that we're almost there, the next thing says copy Q16. That's Q15 now. Q15 dot copy. All right. Then take the transpose of Q16. So we're going to do the transpose of Q16. That's just Q16 dot T. And then let me just do this because there are a lot of so you can just do Q16.T. That's how to take the transpose. So the transpose, what the transpose is doing is converting all the rows into column and columns to rows. So that's what your transpose is doing. And then the next thing says that subtract 125 from the first column of all the rows. Take the transpose of the array again. This puts it back to its original state, making sure that all the changes are saved in Q16. So you want to subtract 125 from the first row of all the columns. So the first row that is here of all the columns, that is this, everything here. You want us to subtract 125 from it. So I'm going to just do something quickly. After taking the transpose, right, we have to select the first row of all the columns. How do you select the first row of all the columns? That's the you're selecting the first row of all the columns, and then first column rather, subtract first column of all the rows, first column of all the rows. That is this column, first column of all the rows. That is all of the rows, comma, everything in this location 0, right? You want to subtract what from it? 125 from it. Sorry, we've overshot our time. In 4 minutes we'll be done. Quickly, minus 125. Let me see how far I can rush. And then they said we should take the transpose and put it back. You should do the transpose again and put it back. So we just say Q16 equals to Q16 dot T, and then you have Q16. Sorry. Oh, it didn't correctly align the transport. Let me do it properly. Let's do the copy again. Let me do it one after the other so that we can have we have Q15, okay, Q16 transpose. Now Q16 minus, so we subtract what from it? 125 from the first column of all the rows, okay, which is done here. All right. Then take the transpose. Okay. .c. Okay. And then there's a mistake somewhere. I'm trying to figure out where the mistake came from. Take the transpose of the QT, this Q. Okay, I didn't save the transpose. So let's take note that when we are doing our transpose, and we have to be careful of our saving, and so that we'll be able to get the right answer. So because I needed to save the transpose to Q16, so that it's going to update what is on it on Q16, and that's why I'm having this. So now we are on track. Let's move forward quickly. Q17, reshape Q7, create a copy of Q16, right? Q16 dot copy. And then we shape Q17 array to this shape. Note that 3 values in each of the rows are red, green, blue values. So we need to use our reshape function now. How do we do that? It's just to use our reshape function. So I'm just going to do this that I've done before now. First of all, let's check the shape of this Q17.shape. This is it. So we want to reshape it to this shape, and you can just do this, the reshape, and now you see that your Q17 has been reshaped. Okay, so you have your answer. Now cast the entire Q18 as integer. That is using our as type now, our as type function that we've used earlier before. So we're going to cast it as integer. And how do we do that? We can just say Q18 dot as type int, and that would give us we've updated the data type to integer. You can see that it has converted from the floating point numbers to integers, and we have this. Now let us uncomment this, and let's see the results of what we've been doing since way before now. And we have our picture. So what a long walk. It took us over an hour to come to this stage of having our picture, but I'm sure that a lot of people, have probably lost some persons, but don't worry. When you go through the recording, you'd see how to go about that as well. So now all that we've been doing, eventually you can see that we've converted that long text to the image, and then we can also create the variable that is the string. Can of course add code the string. So it's just for us to create the variable Q20, and then put the string using our print statements, print all of this into the picture phrase, and then that is the final results here. All right, I believe you learned one or two things from this. And I can share this with you as well. Maybe I'll upload it on the LMS so that you can have access to it as well. So do you have any question? Our time is far gone. Sorry, we spent lot of time before. I mean, we took much of our time today. Do we have any other questions? Do you have questions? Okay. All right. So thank you all so much. So this NumPy comes with practice, right? So it's just a simple use case of using NumPy. There are other ways you can also use NumPy. You come across it by trying out different projects. All right. So from next class, we'll be dealing with pandas, how to do data manipulation and more interesting things. So please don't miss the class, the pandas class. And we have a mentorship session coming up on Saturday. Please try as much as possible to attend. It's going to really help you. Come with your questions. We're having our mentors join us on that call. So we'll be focusing on careers in data, opportunities, and use cases. So on that Saturday, we'll be showing us how to build our own personalized AI application in 15 minutes. Somebody might ask, is that possible? Yeah, an AI application that you can integrate into your website or maybe your mobile application. So that's just an icing on the cake for as many people that will be attending that session. Please don't miss it. Some person might be asking, so why do I have to go learn data science, AI, when I can just build my own application within 15 minutes? But when on that day, we'll be explaining all of that to you. All right. So if there are no other questions, I think we'd have to close this call. Thank you all so much. Thank you everyone that stayed around even to the end. I hope you learned a lot. Thank you, our volunteers. Okay, I think I saw one of our volunteers around helping us to do some tidying up and putting things together. Thank you so much, everyone. We appreciate your efforts. And I'd always mention, if you also want to support this program, we always welcome support. Thank you for people that have been donating so far. Thank you. And I would want to encourage you all to don't give up. It's the journey is very amazing. And once you get to know all of these concepts, it's going to really help you in so many ways. All right. So let's keep learning and enjoy the rest of our evening. Thank you. Have a great evening. Bye.